Hello, can you guys hear me fine? Great. Thanks everyone for coming. Let's get started. First of all, the formalities. I'll introduce myself. I'm David Simard. I'm a senior software engineer at Red Hat. The things I do, I'm mostly involved in RDO, so it's open source packaging for RPM-based distros. Basically, we take vanilla upstream projects, we make RPM packages with them, and then you can roll out your own stuff. I do some dev things. There's not much I can't tackle with a mix of Python and Bash to create the tools that we need. I do some DevOps things to keep my sanity and be efficient. I need to automate a lot of things. So that involves Ansible, Puppet, Jenkins, Soul, and all that nice things. And I also do some system things. So RDO needs some servers to build, test, and release all those packages. So I try to make sure that we're doing well on that end. The things I did, before that, I spent 10 years at iWeb, which was acquired by Internet about 3 years back. In the last couple of years there, I helped them with their public cloud multi-region. It was really, really fun. And other than that, I was mostly a sysadmin DevOps kind of guy, where I tried to make sure that iWeb's infrastructure was up around the clock, including the weekends. So let's get started. So before we dig into the details, I just want to make sure that we're on some sort of the same level. Not everyone is familiar with OpenStack and Ansible, so I just want to cover a little bit of the basics. We'll get into Ansible first. So Ansible. Ansible is a configuration management and orchestration tool. It's a bit in the same family as Puppet, Chef, and so on. The thing about it is that it's agentless, so it runs on your desktop, on your laptop, whether you're running Linux or OS X. I haven't really tried to run it on Windows, so I don't run Windows anyway. It's a Python open source project. It's on GitHub, so you can send pull requests. They love that. They have a ton of those. Ansible was acquired by Red Hat about a year ago. I keep getting asked when we will open source Tower. It's coming. There's no ETA. So let's look at just a quick example to show what Ansible is about. So maybe you were working on production stuff about 2 years ago. There was this shell shock thing. It was not very fun. There was about, 6 CVEs, and you had to patch everything. It was really easy to exploit too. It was a complete mess, and you needed to update Bash everywhere. So there's 2 ways you can use Ansible. One of those ways are ad hoc commands. So straight on your command line, you can do, here in this example, we use the package module to update Bash to the latest release on all of the servers defined in the host inventory. So that's one way of running Ansible. The other way of running Ansible is through playbooks. So playbooks is where Ansible draws its biggest strengths. That's where you're able to orchestrate your things across your different nodes. You can have different roles. You can feed in variables. You can have conditions, and that's what makes it really powerful. In this really simple example, on Debian-based system you have apt, and on RPM distros you have yum. So here in this very simple example, you have a fact. So Ansible collects facts about your systems to be able to do things with them. This is a really simple example to tell, well, I'm running this one playbook across all of my hosts, but it might have a mixed of Debian or Ubuntu host and CentOS and RHEL hosts. I don't know why they want to do that. But anyway, you can manage different hosts just like this in this simple example. So just, I hate to do, I'm sorry, but just a quick show of hands. Is there any OpenStack operators in the room? Do you operate a public cloud, private cloud, stuff like that? Okay, so this might ring you a bell. OpenStack has a bad reputation about being complex and hard and complicated to install, configure, monitor, and so on. And thankfully, this is not what this talk is about. You're going to be consuming an OpenStack cloud, not operating one. So let's talk about the end user part. So as an end user of an OpenStack cloud, it's fairly easy. So you have two principal ways of consuming an OpenStack cloud. You have this very beautiful web interface called Horizon. It's a GUI, so web interface, you can spawn your instances and stuff like that. If you're more of a CLI person, well, there's the command line tools that allows you to interact with the different components of OpenStack. So there's so many ways to, and operators, you guys know it, there's so many ways to install and deploy OpenStack. You can have different vendors, different hardware, you can be a Cisco shop, can be a Juniper shop, can be a Dell, Supermicro, anyway. So the thing that OpenStack tries really hard to do is to abstract all the complexities of hardware and software technologies. So the idea is to, no matter what software or hardware you use, it's going to end up being the same. So that's what it tries to be really hard to do. It tries to be interoperable. In OpenStack, there's three of the core projects. So we have the compute project, Nova, the networking project, Neutron, and the storage project, block storage, Cinder. So I like to mention these three projects because, like Nova, you can have so many hypervisors. You can have KVM, you can have Xen, you can have VMware, or even Hyper-V. But the thing is, with OpenStack, if you ask Nova to give you a virtual machine, it doesn't matter what hypervisor you're using, it's going to give you a virtual machine. And in the end, it's pretty much going to be the same thing. And it's the same thing with all of the other projects. So you can have an EMC, NetApp, SAN, or you can be using LVM iSCSI. If you ask Cinder to give you a volume, it's going to give you a volume. And that's what makes OpenStack great. It's no matter if the cloud is running Xen or KVM, it's going to work the same. And Paul earlier was mentioning how Node Pool and CI infrastructure, they have these 13 different clouds, or how many different clouds? Well, for example, Rackspace, they run Xen, and then this other provider uses KVM, and it ends up working all the same. So if you were in Barcelona last month for the OpenStack Summit, you might remember this. There were 17 different providers and vendors on stage. So you had like Red Hat sitting next to SUSE, and then VMware, and then OVH, Rackspace, and all those beautiful people. And so what this stunt was about on the live keynote was to demonstrate that on these 17 different clouds that are deployed with whatever technology they're using, you can deploy an end user application, and it's going to work all the same on these 17 different clouds. So, and in the end, it was actually a great success. You see people raising their hands that the deployment was successful. So this was a great way to demonstrate that, well, if one day this provider becomes too expensive or something, you can move to a less expensive one. And if it's two OpenStack clouds, it should pretty much work the same. So what they didn't really mention in that keynote is that they had a little bit of help to accomplish that. Anyone in the room know? Anyway, so we had like some live views of what was happening on the different participant screens. Let's just enhance that. So what we're seeing here, if you're familiar with Ansible, you know what this is. This is an Ansible playbook that's running. So basically, all these 17 different people, they were on stage and used Ansible to deploy their application on these 17 different clouds. It worked all the same. And so Ansible has all these different modules that allows you to interact with your OpenStack cloud. And from anything ranging from glance images to security groups and Nova and so on and so forth. So the secret sauce behind those OpenStack modules is the Python shade library. So this Python shade library is used by other softwares such as Noteful, for example. So shade helps a little bit abstract the differences between the different clouds. Shade is a library in Python that allows you to programmatically interact with your cloud. So it's sort of like if you go Horizon is a web interface, and then you have the CLI interface, then you have Shade that's trying to do its own thing. I told you we'd have an application deployment, right? We didn't do any of that just yet. I mean, let's do that. Deploying an application. Let's talk about WordPress. WordPress is easy, right? It's just a LAMP stack. It's a PHP, MySQL, blog, content management system thing. But it's really easy. But let's pretend that I have like a very popular, I don't know, cat picture blog. It's really, really popular. It's not going to hold on this one machine. So let's look at how we can do a multi-node WordPress installation instead. So here's what a typical multi-node deployment might look like. You have a load balancer that's sitting in the public network, and then you have your private LAN, private network, with your application servers that's talking to your database server. So the database server in this context is a little bit more than that, because with WordPress you can upload things. So just for good measure, we'll also install NFS on that database server so we can upload things and it's stored in a central way. We're going to need the cloud to do that. And I told you it would be free. And I'm going to do that live on stage. I'm tethering data on my cell phone. But before I do that, I'll tell you a little about TriStack. So what's TriStack? TriStack is a free public OpenStack cloud. It really is. That's what it is. But it's not for production. It's like the big, bold disclaimer. They don't want you to use TriStack for production purposes, and they'll actually destroy your VMs like every 24 hours or something. So it's really like to test your application deployments, and that's great because that's what we're doing right now. So for the best interest of time, I don't have, the deployment takes about 7 minutes. I clocked it last night. I'll jump to my terminal here. Nope, that didn't work. Can I do that? I need to drop. I didn't test dual screen last night. Okay, and can I? Here, I have a terminal. Can you guys see this fine? Oops.
You're gonna need to zoom in.
Right. Okay. So, so here I already sort of cheated. I prepared some things, but if I just want to show you that. Can I zoom further? Yes, of course. So I'm doing an OpenStack server list just to show you guys that I'm not cheating too much. Oh, actually I'm on the wrong tab. Okay. See, this is like the cooking shows. See, we're gonna cook a pie and there's already a pie ready. So no, that's not. That's my backup shell. That's in case the live demo fails. You guys caught me, I'm sorry. All right, so let's do an OpenStack server list here. And this is the tab we're going to be running in the demo in. So this is against TriStack. See, it's an empty tenant and everything. So I'm going to run Ansible playbook on site.yaml, and this is the same code that they use for the interrupt challenge that they had in Barcelona last month, but I actually added support for TriStack. Yes, I can zoom a little bit. There you go. So this is the very same code that these 17 providers did on their own clouds, but I went ahead and contributed a patch with Garrett, the whole workflow I told you about all day, and I added the TriStack support. So, live demo. What's this? Okay, that's really sad. Okay, let's. Oh no, I'm really.
Use them too much.
Maybe. Okay. So we'll go to the backup deployment. I'm really glad I got the backup deployment now. That worked yesterday, but yeah. Anyway. So we got this Tri-Stack cloud that's for free. But now that we got a cloud, we still need to prepare and deploy things, right? So what do we need? We need to tell Ansible where this cloud is and what are the username and passwords so that Ansible can actually connect to that cloud. We need a key pair, an SSH key pair, so we can eventually log in to the instances that we create. We need an image because we need to install the virtual machine with something, Fedora, CentOS, Ubuntu, or whatever. We want security rules because we don't want our VMs to be exposed to the public internet without any kind of protection. We need a volume because otherwise we have an important database and important cat picture uploads, so we don't want to lose those. And so we need a Cinder volume to keep our important data. We're going to need 4 virtual machines, 1 load balancer, 2 application servers, and 1 database. And finally, we can actually install the HA proxy, Apache, and all that nice stuff. So, authentication and cloud config. Those are not my credentials. See, so this is something that Ansible can do. Ansible can fetch variables from environment variables. So if you're a little bit familiar with OpenStack over the CLI clients, you can pass environment variables instead. So typically you'll source an OpenRC file and then do your commands. So you can sort of do the same thing with Ansible. And in my demo that failed, I had the environment variables set up already. And then in the application environment, those are values that will pass to different modules later on in the example. So we start with a very, very, very simple task in one playbook. I've sort of cut them together, not in a single thing because I tried, it doesn't fit. And the lady back there would complain because it's not zoomed enough. So here we use the Ansible file module that's used to create files and directories and ensure their permissions and stuff like that. We just create a resource directory that we'll use here right away to generate an SSH key pair. So we have the command module from Ansible. We generate an SSH key pair that we'll use throughout this test. And then I tell Ansible, okay, well, this command will create an ID RSA file. And so if I run this task again, it won't try to create another key pair because there's already one. It knows that it's able to expect that. And then this is the first OpenStack module that we use throughout the playbook. We upload the SSH key pair that we just created. So this is the equivalent of doing Nova key pair create and then passing the public key. So this is the Ansible version. So we say that the key pair, we want it to be present. We pass the authentication information, the region name, because you can have multiple regions. We give it a name. In this case, it's LampStack. And then we say, well, the public key file is called RDRSA pub in our resources directory that we just created. So next, we need to upload an image so that we can install virtual machines with. But we need the actual image first, so we need to download that image. And now for the sake of simplicity, we'll just do a Fedora 24 image. Well, we could use like different images, CentOS, Ubuntu, whatever, or all of them at the same time if you wanted to. But the thing is with images, OpenStack images, it doesn't need to be like actual operating systems. It can just be like prepared data if you wanted to. That can be later attached as a volume, for example. Also the image in this case is downloaded and uploaded vanilla directly from the Fedora project website. But you could also like download an image and then customize it, pre-install packages or something like that, and then upload it so that your deployments are faster after that. So once that we have our image info, we're able to download them. And here what we're seeing is we're using the with dictionary. So what this does is that it iterates over the dictionary that we defined on that last slide. Get URL will download each image and place them in the destination that's specified there. And then we use the upload image we use the OS image module, I'm sorry, to upload image. And the interesting thing that I forgot about in that last slide, let me go back here, is the image properties. So here, we're not doing anything very, very special. We're just passing like the dish show and this sit user. But image properties are just like free-form metadata. You could put anything in there. So an example use case would be, say your images are built through Jenkins or something, and that's driven out of a version or a specific commit. You could reference that in the version so that you know that this image in Glance was built through something specific. So going back here, so we upload the image. It's the equivalent of Glance image create or OpenStack image create. We pass the file name, the name of the image, and then the properties that we defined in the previous hash. So I said we needed security groups or security rules, but security rules are actually inside a security group. So a security group is a container for a set of security rules, essentially. Security groups are what you apply to your virtual machine to apply all these firewall rules. There's really nothing special about security groups, it's just a container. And there's the OS security group module. You give it a name, you give it a description, and that's really it. The fun part is the security rules. So here, I ensure that I use the security group rule module. I specified it's very flexible actually. So you have you can specify the direction, ingress or egress. You can have protocol, TCP, UDP. It's really like an interface over IP tables when you think about it. So really, a security rule is more or less just IP tables rules that will live on the compute node where your VM is hosted. So you can think about it as sort of a hardware firewall in front of your machine. It filters traffic before it even hits your machine. So that's very great. Here in this very simple example, we just make sure that the port 22 is open, SSH, web, MySQL, NFS, and then ICMP for ping. We also need a persistent volume. It's really, really simple. We say that the state is present, so we want to make sure that this volume exists. If we would pass state absent, it would ensure that the volume is deleted. We don't want that. But there's otherwise a couple of nice features provided by Cinder volumes. So by default, in virtual machines, the storage is ephemeral. So when you delete your machine, the data is gone. It's your cat pictures, they're all gone. But if you have a Cinder volume, and then you can attach a volume to a virtual machine, and then when you delete the virtual machine, the volume might or might not be deleted. It depends on the configuration that you put. But by default, I believe it's not deleted by default. Another great thing about volumes is that you can detach a volume from a virtual machine and then reattach it to another. So that's great to pass along data to another virtual machine, or if you're respawning your database server from scratch, for instance. In this case, we're creating an empty volume because we'll mount this volume as an additional disk to our database server. We'll partition it, we'll format it, and then we'll mount it inside the database server. So this is empty, but you could have a volume that is sourced from an image. So that would have whatever content was in the image. It could be an operating system, and you could actually boot your virtual machine off of it. But in this simple example, this is not what we're looking for. So what we're doing here is we're creating a volume with the name db volume with a size of 4 gigabytes. And we're telling Ansible to wait until the volume is ready to move on to the next step so that we're not running into some race conditions. We need 4 virtual machines. So this is the first one, the load balancer. So here we connect all the dots from the things that we just did, the image, the key pair, the security rules, and so on. So we After passing the authentication information, we give it a name. It's called balancer. We use our fedora image that we used earlier. We have a key pair that we want to use to authenticate to the VM. We have a flavor. So I didn't mention flavors earlier, but flavors in OpenStack is a way of expressing the physical resources located to the virtual machine. So how many vCPUs, how much RAM, how much disk space, and so on. And then we have a network. So that's our private LAN that was created for us before this demo that failed. And then we have floating IP pools. So this is a cloud that has floating IPs. When you create a virtual machine, it's not on the public internet by default. So if you want your virtual machine to be on the public internet, you need a floating IP. And so your VM will have two interfaces. It will have the private LAN and then the floating IP. And we apply our security groups to make sure that we're not open to the internet. We have user data and config drive. I'll glance over those really quickly. Most cloud operating systems or cloud images of operating systems have something like called Cloud Init that's pre-installed. So Cloud Init is pretty much what configures your VM when it first boots. It'll configure networking, the host name, the SSH key pairs, and so on. So user data is a way to tell Cloud Init to do something else. It can do some extra things, or it can alter the behavior of Cloud Init entirely. The config drive is sort of the same thing. So the config drive is an ISO that's mounted by Nova for your VM, and it contains all the configuration for your VM. But it's read-only, so you can't modify the config drive. So it's typically used by, for instance, hosting providers that don't have, for example, a DHCP service. The networking info will be in the config drive, and Cloud Init knows how to read that drive config and then configure the networking interfaces inside the VM. And then we need the same thing, but for the application servers, we need two of them. There's nothing special here as with the balancer node. So the one thing though is, I'll draw to your attention. Here we have the with sequence thing. So this is a way to, with Ansible, to iterate. It's kind of like a for loop with increments. So in the cloud config that we did earlier, we had a stack size of 4. So we know that we have 4 nodes. We have a balancer node, we have a database node, and then we have 2 web servers. So here what we're telling is that basically do this twice and call the host names Apache and then 1 and 2 because it's iterating across 1 and 2. So if I would go back to my cloud config and put a stack size of, I don't know, 10, then it would do like 10 minus 2 and then spawn 8 web servers. So it's kind of a way to easily scale your stuff. Also need a database node, and this is it's pretty much the same thing as the balancer node, except the name is database because that's what it is. Although the one special thing about the database node is that, so we created an empty volume earlier, but we didn't do anything with it. So we need to attach it to the database node so that the database node can use it. There's a module for that. It's kind of like Apple, there's an app for that. Ansible has a module for that. So OS server volume, you give it a volume, give it the name of the VM you want to attach it to, and then you can also specify the device that you want it to mount to. So you know what to expect, like where the device will be. Is it VDC, VDB, and so on and so forth. So are we done? No, we're not done. But a status update. This is what the Horizon dashboard provides as an interface. So this is the network topology. We see there's the public internet. We have a software router. We have our private LAN, and then all those 4 nodes that are connected to private LAN. The floating IPs are not illustrated in this, but you like imagine that you have floating IPs in there. So we still need to install all that WordPress stuff. But I don't have time to, I would love to tell you all about installing WordPress. It's really fun. But in the best interest of time, I've cherry-picked some of the great examples of how Ansible is powerful and can help you with that. So here, we talked about dynamically scaling web servers by increasing the stack size. So this is really where the magic happens. So here we have Ansible uses Jinja templates. So that's what it's called, Jinja templates. And then what I'm doing here is that I'm iterating across each host in the web server group, and then adding a configuration in the HA proxy configuration file. So if I remove hosts from my stack, they'll disappear from there when the HA proxy config is applied. If I add a host, they'll be applied automatically as well. But what actually applies that configuration is what's happening here. So we set up HA proxy, we compile the template, place the configuration file, and then we're using what's called an Ansible handler. So Ansible has a concept of handlers where you can notify. It's mostly used for things like restarting and reloading services. So when you're modifying a configuration file, you know that you want to eventually reload your service. So Ansible will eventually do that for you. But otherwise, you can also force the handler to execute immediately if you want to. If you don't want to deal with templates, there's also something like it's called line in file, which is another way to manipulate files with Ansible. Here we sort of do the same thing. We iterate across all the web servers in our group, and then we make sure that they're able to use the NFS server as a storage bucket. If you're still not convinced, well, tough luck, because I don't have that much time to spend on this. And this is where I would go to the working demo, but I'll go to the backup one. Here. No, I need to close this first. Backup tab. And then, would you look at this? We deployed 4 nodes. Eventually, tethering. Remember my phone. So we have the balancer node that has a public IP, and then the remainder of the stuff that's only in the private network. They're not reachable. So I'm going to go ahead and just show you that, last night it actually worked. Here. No. Why are you doing this? Here, we have a WordPress blog. There's no cat pictures, I was lying. So this is what they did live on stage on 17 different clouds. It was pretty awesome. And just to try and... so if you're familiar with HA proxy, you might have seen this before. This is the HA proxy status page, just to show how you can have dynamically scale your web servers and stuff. Let's go back here. So if you're still not convinced, well, I mean, I'll try and convince you. So some other really great features of Ansible, along with OpenStack Cloud, Ansible as a concept of dynamic inventories. So you can have all your hosts in a static file, and it's okay, but you might need something more dynamic. So there's an OpenStack dynamic inventory. So instead of using -i host, you could use -i openstack.py. That'll source your credentials, and then you can use basically the list of servers, and it'll pull also the facts and stuff like that. So you can actually use that as an actual inventory. So and it actually creates some groups for you. So you could say all my Fedora machines, or all my machines that has this name, and so on and so forth. It's really great. Otherwise, Ansible is really, really extensible. So you can do custom actions. I told you there's a module for that. You can do pretty much anything. And if Ansible can't do something that you want it to do, you can do it yourself. It's really easy to hook in. I am by no means a professional Python developer, and I've been working on this project. It's called ARA. So basically, it will record the status of your playbook run, and then provide a really nice GUI to visualize what happened, what failed, what succeeded, and so on and so forth. This is an OpenStack project, so I mean, it's on GitHub and all those nice things. This is all the time I had today, so any questions? Yes?
When using dynamic inventory,
Yes.
can you use variables that are specific to all those? You have variables stored locally that are specific to all the nodes in this OpenStack environment?
I can show you right now if you want. No, it's not. But anyway, it has all the facts that you would normally have during a playbook. So if you want to, like, it even has like metadata like security groups and so on. So you can like filter host by security group and then do something like fork these hosts.
Like, let's say you have two OpenStack environments with two dynamic inventories, and you want to store local variables. So you want to have local variables stored the same way you would have if you were using a static inventory. You would have your variables per host, right? But you want
Yes.
to have those local variables to one of your OpenStack dynamic inventories. Would that be possible?
So the question is, can you have static or local variables while using an OpenStack dynamic inventory? The way I would see this work, and by all means try it out. I'm not sure, but when you're running your playbooks, you can have variables files, and then you can also have group variables. So in Ansible, the topology is group vars. So you can have a group vars that's named after the same thing as your OpenStack group. Say, I don't know, like balancer. So a group called balancer, and then group vars balancer, and then do some stuff in there. That would probably work. I'm not sure, but maybe.
Thank you. Great talk.
Thanks. Any other questions?
Good time for one more, so long as we can do a screen transition at the same time.
All right. Well, thanks for your time.